Okay, before we go on, I will explain the project assignments. This software architecture is quite abstract topic actually. So we explain the concept, but you can only really understand it if you do it yourself. And actually that's also the goal of the project. Open this. The project, so if you have, so we try to actually do a role playing in this project. Imagine we have kind of organization company. There are many stakeholders in the company. One of the important stakeholders persons is the architecture team. So actually every company, software engineering company who builds large complex systems should have an architecture team. And in this project you will actually play that role. An architecture team defines the cross-level structure of the system to be realized, has a very global understanding of the system, overall understanding of the system, provides a technical vision of project, can direct technical teams and communicate design decisions and the rationale to the stakeholders. It's one of the important stakeholders in your systems, in your project. Well, if you develop system, software development system, software system, we can talk about 4 P's. Persons, so there are requirements analysis, domain analysis, software architects, the process, the software architecture design method that you will follow. So domain-driven architecture design method. We will adopt the synthesis-based architecture design, its acronym is SYNBAD. The product, what are you going to develop? Typically you will have requirements, domain model, software architecture. And this all together is done actually in the project. So you follow as a team, follow some process and develop some products. What's the goal of the project? Learn to operate in architecture design team. What does it mean to be an architect? It's just role playing, you don't have that much time, but it's education for education purposes. It is useful. Learn to apply architecture design process. Maybe actually we are explaining the process, so we did requirements analysis, domain analysis. We will see also technical problem analysis, applying architectures, evaluating. So all the necessary steps in architecture design you have to follow. Learn the fundamental architecture design concepts by doing this. Probably you will also experience some obstacles. This is okay. Experience obstacles in designing our teamwork, communication, and presentation. We will have several groups. From each group, one student needs to present the architecture. The project group represents, as I said, an architecture design team. The team consists of 2 persons. We will have maybe one team with 3 persons. So that will be accepted. We will see. Each team should design a different architecture, different system, and you have to define your team yourself. Usually you need 3 to have a group, but we have now groups of 2. If you cannot find a partner, just mail me. I will define the groups. Okay. Do this as soon as possible. And I'll make a list and then define the teams. Project resources, we have time. Not that much time. The project resources, we need the time. You have the time, the person's library for domain analysis. You might need to check some books, the internet, lots of resources there. the course note slides to check the textbook, to check the process. Consultancy, I will be available during the summer, during the whole course. So you can just contact me anytime, just mail or phone, call me. We will have also a mandatory consultancy meeting that will be the week 4 in 2 weeks. It's on Monday. Then we will have a group discussions with the separate groups. I will make the plan for that. So it will be during the course hours. So we will not have just lectures like that. But then the complete morning will be just dedicated to discussions. Okay? The product system. What kind of case should we select? Not an ATM machine, please. But some relevant complex case for which you can define an architecture. You will have to do architectural requirements analysis. You have to define a domain model, derive the conceptual architecture, and later on also architectural views. We have to apply patterns and evaluate it. So if the architecture is too simple, you might not. These will be also very simple, but the problems will also be evaluated with respect to their complexity. So try to be sufficiently complex and relevant. What are the project tasks? Requirements analysis consists of stakeholder identification, identifying the architectural drivers, and modeling, requirements modeling. Okay. Requirements analysis is pretty the same to object-oriented design, but here we are focusing on a gross-level structure, so architectural requirements analysis, and in particular the architectural drivers are important here. And technical problem analysis, I will explain this, so it's a step between the requirements analysis and domain analysis. You will have to define a problem model which defines the concerns. Domain analysis, which we discussed today, you have to explain the identified domains, the knowledge sources, and evaluate these, extract concepts, structure concepts, and define it in the domain model. Domain model definition, glossary, conceptual model, and future model. And for this part, you will need to map this domain model to architecture design, software architecture, represented in UML. This is the so we have seen how to represent. Typically you can use the stereo-based approach where you define the domain, so where you map the domain model concepts to stereotyped classes. Okay. So actually, you have to select a case and define the architectural document. This is the midterm project, so it will not be complete yet. This will be the document for this part. So typically start with introduction, problem statement, or cases about this and that and that. You explain the case. You have to define the process, the approach for architecture design that you use, which is in our case the synthesis-based architecture design and domain-driven architecture design process. A section about requirements analysis. These are the stakeholders, these are the concerns, and this is the requirements model. Section about problem analysis, where you identify the key problems, the concerns. Domain analysis, a top-level architecture design, and architecture of the subcomponent of the architecture, of the top-level architecture. Summary conclusions, and don't forget the references. See the course homepage for the detailed criteria criteria about the evaluation. You have to define a document, excuse me, and present it. Present the architecture. Architect is an important role in the organization. We said it's not just the technical guy, but also a person who can also communicate well, present well. Okay, the architect documentation should be well written, but also you should be able to present the architecture. For the presentation, you have about 20 minutes. You have to prepare PowerPoint presentation and allow time for questions. It's about 20 minutes. It's not that strict here, but please try to not violate too much. You have to submit the presentation the day before, or just before, preferably day before, so that I can just store it on my laptop and we don't lose time. Or just the morning before, just 1 hour before the course is also possible. See guidelines on the home page again. Okay. So the project has been split into midterm project, final project. In the final project, actually, we will just continue where we stopped and focus on how to implement the architecture, how to map to analysis and design, focus on architectural views, define the architectural views. So we said, we will see that later on, architecture has not only one structure but multiple structures. You have to apply patterns and you have to evaluate the architecture. So in the end, the architectural document will be complete. So you have to keep the original results and documentation. Okay. This is the schedule, the important dates. June 22, that's next Monday. Before that, you have to mail me about your architecture team with the topics and student names and email address. If you don't have a team, just mail me. If you don't have partners, cannot find partner. If you have problems about topic, mail me or call me. Okay? I can help. So all the teams should have different cases and should be sufficiently complex. So you have to mail me the topic and you will get an acknowledgement from me if it's approved. July 1, you have to deliver the hard copy and send electronically. And we will have the project presentations. So that's it, what I can explain. Questions? It's clear. Did you start to form the teams already? So for this case is actually requirements analysis, problem analysis, domain model, map that to architecture. Okay. Good. Okay. The synthesis-based architecture design, that's the process that we will follow also, that you need to follow in the project. It's a domain-driven architecture design approach, which means that it includes an explicit domain analysis process to identify the domain concepts and derive the architecture based on these domain concepts. I will explain this process. So first, what is synthesis? Then provide an example So I will explain the process using an example, based on ambient intelligence device. Then, I will explain the specific processes, technical problem analysis, which we have not considered yet, and solution domain analysis, which I have discussed actually before this. Architecture design and synthesis process. So this we have seen in the morning. We have set of requirements. We know it, but how can we derive the solution? And we said, okay, the requirements are not a solid basis for deriving the architecture. For that, instead, we said, because the gap is quite large, and we said we have to look at the domain. Okay? And we said we have to identify these domains, select the knowledge source, and get the concepts, knowledge concepts. Imagine for this driver monitoring system, we say, okay, we did the architecture requirements analysis, and then the next step is to find the domains. Well, what are the domains? Where to look at, how to scope the domain. Okay. That is, we said, actually, you can use the taxonomies. We said it can help you to identify the domains. So this is the requirement specification. It's architecture solution. It's quite large. But if there's still a problem. The gap is still quite large. So as a driver monitoring system, go find domains. But based on what? Right? You actually don't know. If the taxonomy can help you. Actually, we tacitly said we can identify domains, but it's not that trivial. Instead, we say you should first identify the technical problems, the concerns, even before identifying the domains. Okay, what are the? So you have architecture requirements analysis, and actually what is important there is to identify the concerns, the problems, the technical problems that need to be solved to develop the system. So we consider this as actually as a problem-solving process. Architecture design is a problem-solving process. It is based on a problem-solving model, which is like here. So we start with the requirement specification for any problem solving. So we have some requirement specification. What we first do is actually, in general, is to try to define the problems, the concerns. If we have defined the concerns, the problems, then we search for solution domain. Okay. If your requirements analysis is quite extensive, it might already overlap with problem analysis. It might already state what the problems is. Once we search the solution domain, and based on the solution domain, we derive the concepts and define the solution description. We could have alternatives, alternative solutions. These alternatives are evaluated with respect to some quality criteria. Okay. We are not interested in all alternatives. We select a feasible alternatives, and once we have the alternative, we implement this. Okay. In the artifact by itself can again impact the requirements specification. If you look at existing engineering disciplines, the mature engineering disciplines, we can observe that they largely follow this process of problem solving. Okay. Engineering is done by what we say is a kind of, usually by a synthesis process. Okay. First, you have a requirements, but always the problems are stated. What's the problem? Is specified. What is the solution domain? And there's an alternative analysis process. So these are the three essential processes. The technical problem analysis, what is the essence of the problem. So we get the requirements, the stakeholders, they wanted something to do, but what is the real essence, the real concern? So we should provide that. Second one is the solution domain analysis, which we have discussed. What are the required solution domains? What are the knowledge sources? How to model this? And the third, alternative space analysis. What are the alternatives in the domain? And how to evaluate these? This together actually it's relate the interplay between these, we can call it's a synthesis process. Based on that, on this synthesis approach, we have defined the synthesis-based architecture design process. Consists of requirements analysis, problem analysis, domain analysis, alternative space analysis, and finally architectural specification. This is an example, it's our own example of a domain-driven architecture design approach. So every domain-driven architecture design approach should have an explicit solution domain analysis process. In our case, we have also a problem analysis to focus more also on the concerns. This represents the overall process, so we start at 0, then with 1, requirements analysis, follows with problem analysis. After problem analysis, we can follow with domain analysis, and then there can be iteration back to the requirements analysis or to the problem analysis. Once we have identified domains, we can look at the alternative space analysis and then finally architectural specification. Okay. So let's look at an example of synthesis process, of example in mature engineering. So define a process design for producing the ethylene to 190 proof ethanol. This is from this textbook, Biegler, Systematic Methods of Chemical Process Design. What's the process? Well, let's analyze this. Here they refer to two technical encyclopedias for chemical industry to state the problem and to derive the chemical process reactions. They have a chemical engineer's handbook. From literature, analyze the chemical elements' crucial properties such as the cooking point and the waste produced by chemical processes. But they do an explicit domain analysis process by looking at literature, analyze the tables, calculate whether there will be a feasible solution within the given cost limits. After thorough analysis, the synthesis phase is started. Here the design, derive the flow diagram from the literature, analyze the flow diagram and represent mathematical models of the various alternatives by using again the tables, formulas and equations from literature. Together with the constraints, select the most feasible alternatives. This is just a normal, ordinary engineering design process. What do we see? You look at, usually you have a technical problem analysis. What is the problem? Okay. This is a requirement, but they even refer to the literature to state the problem. Then there's a look at the encyclopedias and literature to analyze the domain, so for solution domain analysis. Finally, we have an alternative space analysis. We make mathematical models and select the most feasible alternatives. We say this is is also a synthesis. So the process that we will follow will actually also is also a synthesis-based design process. It includes problem analysis, domain analysis, alternative space analysis. Pretty the same as the mature engineering disciplines. It can be compared to the also the other domain-driven architecture design approaches, but in the synthesis-based architecture design, the process of problem analysis is also made explicit, and process of alternative space analysis explicit, plus the interplay between these three processes. So while doing a project, while following the process, you have to do architecture requirements analysis, problem analysis, domain analysis, and map that to architecture. So the synthesis-based architecture design. We will synthesize the architecture by looking at the real problems, the technical problems, by looking at the domain concepts, by looking at the alternatives. That will be the process. I will explain this process using a case, a portable storage container in ambient intelligence environment. This was a project that we did together with Philips, the Netherlands. What is ambient intelligence? It's a concept used where intelligence pervasively exists in the surrounding environment. Such an environment is sensitive and responsive to people. The environment includes devices, application servers, and their interfaces. So you could have an intelligent room, an intelligent classroom, where students have devices, where there are sensors, where they react on the entrance of persons in the classroom. So it's an example of ambient intelligence environment. There's everywhere intelligence. Basically, ambient intelligence. This is the view from Philips. Consists of 4 important entities. First of all, ubiquitous computing. You need the devices, the ambient agents that people can carry. These devices communicate with each other in an intelligent way. These devices have intelligent user interfaces, and there are sensors everywhere. So the sensors are aware of the devices are aware of each other. So intelligence everywhere. This is the context. In the future, it is expected that our homes and our environment will consist of a distributed network of intelligent devices that provide us with information, communication, and entertainment. You have now also quite intelligent mobile phones, right? The kind of iPhones. It's a device. So you have some device, but also the environment should be intelligent. Well, what was the project here? Design an architecture for intelligence device. Not the sensor, but just the device. Where you can store which is sensitive to sensors, which can be observed, which includes lots of intelligence, is responsive, and in which you can store and exchange media in a heterogeneous environment. Design architecture, design the system architecture, using a synthesis-based architecture design process. That was the project here. For that we had some example scenarios. Example scenarios were defined to grasp the problem, typically at the architecture requirements analysis. This is an example, personalization of PSC. So John just has bought his new PSC, the personal storage container. It's the intelligent device. Before he is going to use his PSC, he has to do a short setup for his personal profile, and he walks towards the park. On a quiet place in the park, he enters his username, full name, keeps the remaining personal information fields empty. As his key interest, he adds cycling, watching, action movies. He appends his friends Kevin and Maurice to his friends list. So you have intelligence defined. You can just personalize, customize. You define your interest, etc. Scanning the environment. So you have the device. Suddenly his PSC informs John that one of his friends, Kevin, because he put his friend Kevin customized in the neighborhood. So then the device is intelligence, then gets it in the friend list zone. So the PSC informs that Kevin is in the neighborhood. When he looks around, he sees his friend walking to a bench 30 meters away from him. John clicks on the icon of his friend on his PSC, and Kevin is notified that someone wants to connect to him. Just intelligence. So, etc. This is automatically connecting to a store. Another example, when walking along a store, John doesn't know what happens to him. His PSC turns yellow and he sees a pop-up advertisement. It's a shop, he looks, then you get an advertisement. Because device is intelligent, environment is intelligent. Okay. He has heard the song of them. It's on pop-up advertisement of U2. And then he enters the shop and pays, and then gets the single. These were example scenarios to grasp what the system should be like. To grasp, to get an intuition. So now we will come to the technical problem analysis. Technical problem analysis is a process between the architectural requirements analysis and domain analysis. These three processes can overlap, but they have all a specific goal. Requirements analysis is just to identify the client's wishes. Problem analysis is actually, the goal here is to identify the essential concerns. What are the concerns that need to be developed? Could be independent of the requirements. Okay? Like we have a domain independent of requirements, problems can also be independent. Because there could be just well-known concerns. What are the essential concerns? In the problem analysis, we focus on the essential problems, and as such, so try to support the domain analysis. So we said, okay, to understand, to define a stable architecture, we have to understand the domain, requirements analysis, understand domain, but where to look at in the domain, okay? And that's typically the goal of the technical problem analysis. It provides you the concerns, the problems that needs to be solved. Once you have these problems, you can identify the domains more easily. Problem solving is a ubiquitous activity. It has been studied in different disciplines, like in cognitive science, where problem solving is a systematic recurring mental process. Problem solving in design in general, basically from work from Newell and Simon. Problem solving in mathematics, how to solve mathematical problems. Problem solving is for inventors, problem solving for anything. This is a nice book from Karl Popper, All Life is Problem Solving. It's more philosophical, or philosophy of science, but it's worth to read it. So we have also problem solving in engineering. So that's actually in the software architecture design process. It's the second process. This is it's a very general process, not very, but what we actually do is once we have the requirements, we try to generalize and abstract from these requirements to define the essence of the problem. If the requirements is well written, we might be lucky and can directly define the problems. But usually that's not always the case. So we identify the problems, we identify sub-problems, and prioritize these problems. So from requirements, we map to technical problems. Problem is defined for particular stakeholders as specified in the requirements model. Covers a particular domain and context, and is related to manage or enhance some quality concern. Okay. So it is for stakeholders, for some domain, and for quality. Okay. These are actually the three categories that we will look at to define the essential problems. We have seen these were the domains of software engineering, application domain, mathematics, computer science. So for searching at the essential concerns, the technical problems, we will first look at this, so these are the domains. We need to look at these domains. So three categories: problems from stakeholder requirements, that's one category. Problems from the domain, and which we said can be subdivided into application domain, computer science, mathematical, and problems from quality requirements. So it's an explicit problem analysis process. It is kind of independent of stakeholder requirements analysis. Here you say, okay, what is the problem? Let's look at these stakeholders. If you have the drives, the typical drivers could be maybe defined as the technical problems, but in addition we also need to look at the domains. So remember that we said not have, besides of the stakeholder requirements, we might also have domain requirements. In addition, we will look at quality requirements in an explicit way. So let's look at these one by one. Stakeholder, domain requirements, quality requirements. The problems from the requirements. These are the stakeholder requirements. Here we try to identify the essence of the problem. Okay. We analyze, categorize, contrast, compare. It's not just a view of the stakeholder, but we try to define the concerns. So like we could discuss, the stakeholder can say we would like to have we have lots of data, it should be consistent, and there are many processes. So there you could say derive to like, hey, we need a concurrency control. Is that your problem? Yes. See that? Concurrency control problem, or scheduling. Need a data consistency, and in case we can have lots of failures. Oh, do we need a recovery? Okay, it's a recovery, it's an independent problem. How to define recovery? How to define concurrency? In that way, we try to identify the essence. It's not about the specific application entities, but it's more general, more objective. This is a concurrency problem, real-time problem, synchronization problem, which are also explicit in the literature. Okay? We might need to negotiate with these stakeholders here. So these are the stakeholders problems. What about domain? So we said to identify the domain problems, we have three kinds of domains: application, mathematical, computer science. Application domain. We ask these questions. Oops. We determine the application domain entities. We determine why these entities are required, who is using it, how to model application domain entities, how to model the relations, what kind of problems are considered essential for the entities, what is the level of modeling and intelligence, what are dynamic properties, what is currently available. For example, insurance system domain. What kind of problems do we need to solve there? Okay? We can only get these problems if we analyze that domain. Okay? Computer science domain problems. So you have some background, lots of background on computer science. You got some lectures, courses, and typically an architect should have also this computer science domain knowledge. If you are faced with some requirements, you have to develop some system. Typically, you will use that knowledge to identify the problem. So you can ask questions like, what are the computation models, entities, relations, functions? Is it an evolving object modeling problem? Is it an algorithmic design problem? Layered system, is it a distributed system problem? A database problem? Interpretation, compilation problem? A graphical user interface problem? Device control interfacing problem? A specification problem? A real-time schedule, parallel system design, secure system, etc. They are just problems that are defined in the computer science domain. Finally, mathematics. If you ask, is it an optimization problem? A simulation problem, transformation, constraining problem, classification, recognition problem, probabilistic, stochastic, uncertainty problem, testing, etc. See, before doing the domain analysis, we ask these questions. The third category is the quality problems, where you actually go through the list of quality requirements and you ask, what should be the robustness of the system? What are the performance requirements? What are the requirements for security, safety? Do we need some reuse? What are the evolution problems? What are the priorities, trade-offs? See, typically these might not be mentioned in the requirements analysis. But here you ask it explicitly. You look at the application problems, computer science problems, mathematical domain problems, and quality problems. Why do we do this? Actually, to prepare the domain analysis. Because once we know what the problems are, we can more easily identify the domains. So we have the whole list, stakeholder problems. We make a list of problems, application domain problems, computer science domain problems, mathematical quality problems. We list them, analyze, compare, and consolidate. We get the final set of problems. How do we describe that? Typically, you could have, again, we have a requirements model, domain model. We have also a problem model. This is one example. Every problem has some identifiable name. It could be indexed, some unique identifier, problem 1, problem 2, problem 2.1. Description of the problem, including the context, the initial state, what is the current system, state of the current system, the desired state. So we don't have concurrency control. We need to add concurrency control. How urgent? What's the priority? Type of problem, stakeholder, application domain, computer science. And the problem could have sub-problems and solution domain. And here actually we match. If we define this is the problem, and then we try to define the try to identify the related domains. Let me just give one example. So this is of the PSC, the overall problem description. We used a simplified problem model, not this one, but simplified. You just name, initial state, desired state. This is a top-level problem. We say how to design an architecture for a portable and mobile device which can store and exchange assets in a heterogeneous network environment. Initial state of the current project, the current organization. The PSC can be best compared with the MP3 players of today. Storage capacity is not as large as it will be for PSE, and the same can be said for connectivity aspects. Some wireless standards are already applied. The current system, initial state. Desired state, a device for in-home and on-the-move that fits into a pocket with which the user can exchange personal or commercial assets with other users and devices. Those devices can also be portable, but also audio and video equipment or personal computers in the home network of the user or in public. It's a top-level problem. Then in this top-level problem, after looking at the application domain, computer science quality problems, we can list the sub-problems. How to store assets. It's a problem that needs to be solved. It's the initial state, and this is a desired state. A device with the storage capacity with which the user can store the entire collection of music, movies, pictures, and documents. The user does not have to think about where to store the assets. So just an explicit problem description. How to retrieve assets in a similar way. How to personalize. It's all, so it's initial state, desired state, and in the end we get a set of problems, explicit problems, which need to be solved to define the architecture. Okay? And which is an intermediate step between requirements analysis and domain analysis. So this will help us also to identify the domain. In this case, we had how to exchange assets, how to store assets, retrieve assets, how to use, how to create assets, how to personalize the PSE, how to make PSE portable, how to realize shared applications, how to limit cost of PSE. And this was typically based on by looking at quality concerns. This is example problems. And we can define this in a problem diagram. Okay? So at the top level we have the PSE, P0, and we have some sub-problems which need to be solved to define the architecture. What's the next step? Solution domain analysis, right? So then we will just proceed with this, with taking these problems into account and try to find the domain's knowledge sources till we get the reusable concepts.